Welcome back. Problem 6-60. So statement is the beam is subjected to a movement of 15 kips into feet. Determine the resultant force and the bending stress produced on the top flange A and bottom flange B. Also compute the maximum bending stress developed in the beam. So you can see this is the cross section of this beam, clear, and the moment that is given as 15 kips into feet. All the dimension of this cross section of the beam is given over here. The thickness of this flange is 1 inch, width is 5 inch, the height of this web is 8 inch, and this flange having thickness of 1 inch and flange width is 3 inch. So we have to find the stress at the top and bottom of this upper flange, which is A, and similarly at this bottom and top of the flange B, and we have to compute the forces. So let's start with the solution. So as we know that the bending stress is given by using a flexure formula, that is M minus M into Y divided by I. So we do not know I, and since this beam is not symmetrical, clear, so we will find first its neutral axis as our neutral axis. So for neutral axis I will write the formula that y bar is actually the location of neutral axis. So that is equal to sum of y dash into A divided by sum of area. Now you can see that we have 3 areas. For example, we have the first one is this one, the second one is this web, and third one is this one. So if you look at the first one, clear, so the first one will have area of this 5 by 1 inch. So this is the area. So I will write it 5 by 1. 5 by 1. This is the area. Now what about y dash? So if you take this upper surface as a reference, so y dash will be this one, the half of 1 by 1 inch, which is 0.5 inch, and that is equal to y1 bar. So I will write into 0.5 plus, we will go to the second portion, and second portion is this web. So this area is 8 by 1 inch. Clear? So I will write it 8 multiplied by 1. And what will be its center? So 8 is the total height. So 1 will be its center. 1 will be the center. Now from the topmost, this distance will be equal to 4. This distance will be equal to 4 plus 1, which is y2 dash, and that will be equal to 5. So I will multiply it with 5 plus the third area, which is this one, and this area is 3 by 1 inch. 3 by 1 inch. So I will write 3 multiplied by 1, and y3 dash will be equal to 9.5. I will show you. You can see that the half of this will be 0.5. So 0.5, and from this top, this total distance will be 9.5. Also, if you look, the total height is 1 plus 8, and half of this will be 9.5. So this is y3 dash. So divide by sum of all areas. So first area is 5 into 1. The second area is 8 into 1, and third area is 3 into 1. So if you calculate it, you will get y bar is equal to 4.4375 inch. So I will delete these things so to clear. So its center, if I represent the centroid, so centroid will lie at a distance of 4.5 from this face. So this is the neutral axis. So this distance is y bar. This is your y bar. I will write it as y bar, and that is equal to 4.4375. Now you have this y, so definitely you can easily find the moment of inertia. So moment of inertia will be equal to I1 plus I2 plus I3. So for first body, its moment of inertia is equal to 1 over 12, 5 into 1 cube, because you can see that this width is 5 and this height is 1 inch, plus AD square plus area. So area is 5 into 1. And what about D? D square. So D is distance from neutral axis to the centroidal of this first part. So this is D1. Clear? And this D1 is equal to y bar minus 0.5. So 4 y bar is actually 4.4375 minus 0.5 whole square. So this is the moment of inertia of first part, plus 1 over 12. I am going to talk about this, that is second portion. So its width is 1 and height is 8. So 1 over 12, 1 into 8 cube plus AD square. So area is 1 multiplied by 8, and D square is, now you can see that this 8 is the total height. Clear? And its centroid will be at 4, at a distance of 4, exact at the half. So this total is y, and this is this distance is from this top, this is 5. Clear? So I will write 5. If you subtract 4.43 from 5, you will get this distance, and that is D2. So 5 minus 4.4395 square, plus the area, moment of inertia of this portion, this, and this was your third part. So 1 over 12, its breadth is 3 and height is 1 cube, plus AD square. So area is 3 multiplied by 1. And what about its distance from neutral axis to the centroid? So this is its centroid of this portion. So this distance is actually equal to, if you look at, we have already discussed that this total height is 9.5. Clear? So 9.5 minus this y dash will give you this distance, and that is your D3. So I will write 9.5 minus 4.4395. Clear? And that will be square. So when you calculate it, definitely you will get the total moment of inertia, that is equal to 200.27 inch power 4. So this is the moment of inertia. Okay, now we know that using Flexure formula, and the Flexure formula is sigma is equal to minus m into y divided by I. So we will find sigma A, that is at the top of this plate. So I am talking about this. I will copy this, so, and we'll paste it downward so that you can get a clear picture of that. So basically I am talking about this flange top surface. Clear? And we have discussed that y dash was at a distance of 4 point y dash was 4.4375 inch. So for top, we are taking movement is already given, that is 15 kips into feet. So 15 multiplied by 12 is, will convert it into kips into inch. And what is y? So y is distance of this distance from neutral axis to the topmost. So sigma a top is there is a minus sign, 4.4375 divided by I, and that is 200.27. So sigma a at the top of this flange comes out to be 3.9883, and that will be minus, and the unit will be KSI. Now what if I find the sigma A at bottom? So bottom is this portion, clear, and this distance is y, it will be equal to 4.43 minus this 1, clear. So this will give you y. So again minus m into y divided by I. So again minus 15 into 12 will convert kips into inch, and y is now 4.4375 minus 1. So divide by this I, which is 200.27. So again when you calculate it, sigma A at the bottom will be equal to 3.0896 KSI. Now we will move toward this flange, and we will calculate the stress at this top portion and then stress at the bottom portion. So I will write sigma B top is equal to minus 15 into 12, and what is y? So y is distance from this to this top is actually 9 minus this total is 9 from this point till this point. This total is 9, so 9 minus 4.43 will be this distance 75. So 9 minus 4.4375 divided by I, which is 200.27. So again when you calculate it, you will get sigma C is equal to as this distance is downward, so this will be minus, minus will be plus. So sigma B will be equal to B at the top will be equal to 4.1007 KSI. Now sigma B at the bottom will be equal to 15 multiplied by 12. There will be a minus sign into, now y will again minus, so it will be minus, minus will be plus, and now this total distance will be from this to this. So total is 10, 10 minus this distance is 10 minus 4.4375. So 10 minus 4.4375 divided by 200.27 will give you 4.995 KSI, or you can say that sigma B at this bottom will be equal to 5 KSI. And you can see this is also sigma max, because maximum stress is defined as the stress that is at a maximum distance from the neutral axis, and you can see the maximum distance from this neutral axis is this one, which is 10 minus 4.4375. So this is maximum stress. Now if you convert these stresses into force, so force at A will be equal to average of top average of uh, sigma top A at top plus sigma A at bottom into area. So what is the area? What is top? And so half of sigma 8 at top is this one, while bottom is this one. These, they both are negative. So, and this area, which is this one. Clear? So I will write minus 3.0896 plus again minus 3.9883 multiply by area is 1 multiply by 5. So when you calculate it, you will get F force is minus 17.7 kips. Clear? So this will be in compression. Okay, now force at B will be equal to average of this maximum, this T, and this value and this. Clear? So I will write direct values 4.995 plus 4.1007 into the area, that is this one, 1 into 3. So 1 into 3. So when you calculate it, you will get force at point B will be equal to 13.7 kips. Now what if I draw the top flange and bottom flange? So let this is your top flange, and that was if I draw it like a 3D shape, so it will be a better and you will also understand. So let this is the top flange, clear, and this is the cutted portion. So at top of flange you can see that maximum stress is this one 3.99, and at bottom 3.08 minus, both are minus. So this will be represented like, say, this is, if I represent it like this, clear, and the bottom one is like this, clear. So you can see that the stress variation will be like this one. So your maximum stress is 3.9883 ksi at the top, and at bottom you will have 3.0896 ksi, and the stress variation will be like this one. Clear? And what about this, that we have calculated FA? So FA will be basically this one. We have converted this stress into force, then this is FA, which is minus 17.7 kip. Now if I draw the bottom one, so bottom one is like this one, clear, and the stress distribution will be the same like in here. Now here the bottom one will have a larger stress and top one will have a lower, so the variation will be like this one. Clear? I hope you are getting it. So this is plus, so it will be in like this. This is the remaining plate which we have cut it, and the value of upper one is 4.1007 ksi, while this one will have 4.995 ksi, and this force will be FB, and this FB will be like this one, like it will be like this one. This will be FB, and FB is 13.7 kip. So this was all about this problem 6.60. I hope you have enjoyed this video and you have a clear understanding about such type of problems. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.